Alright guys, so that first, that first slide, that first page, top of the page, just to give you sort of a warm-up of the three types of problems you're going to have to be able to do. We'll get some definitions on here, give you a little more clarity maybe, another round of it. So first thing I want to define is the word sector, which you'll see on the on your paper there. If you look at the word sector, it kind of looks like the word section, which basically is what it is. It's a section of a circle, it's a portion of a circle. To define it a little more clearly, I want you to draw one. So draw a line from the center of the circle to the edge, and then draw another one from the center of the circle to the edge of the circle. Of course, you know what those two are called from your pre-algebra knowledge, your middle school knowledge. Any line from the center of a circle to the edge is called a radius. So sector is basically the space defined by those two radii and this curved part, which we haven't talked a lot about, which is called an arc, or an intercepted arc. That space that's inside there is called a sector. So shade that space in. You'll see how beautifully I've shaded mine in. Obviously you can admire my shading skills on that. That blue area is the sector. And generally when we talk about sectors, we're talking about finding an area. When we talk about length, we're talking about finding the arc length, which is a curved distance across the outside of a circle. So put my R's on there for radius. Now you have an idea what a sector is. Basically a sector, as I mentioned earlier, is this fraction of the entire circle's area. So it's some fraction of pi r squared. At the same time, the arc length is a fraction of the entire distance around a circle. Of course, you know the entire distance around a circle is called circumference. So when you're trying to calculate these two things, you're basically taking a fraction of pi r squared, or taking a fraction of 2 pi r, or fraction of the circumference. So I'm going to give you two formulas here that actually are pretty simple once you get the hang of them. The first one, again, I'm using this alpha for area of a sector. You can use any variable you want. If you want to call it a, you can. Where it's a fraction of pi r squared times, a fraction times pi r squared. And this fraction is based on the number 360 because the entire degrees in a circle is 360. So basically you need two givens. You need to find the radius, you need to know the degrees of the arc, the degree of curvature on there. You divide that and multiply it by pi r squared and you've got your distance. Sorry, you got your space, you got your area. The other one I used was lambda on the previous slide for the arc length, for this red distance on here. It looks exactly like this formula. It's the same thing, m over 360. We're going to do some multiplication with that. But because we're talking about distance, we're talking about circumference, we're not going to use pi r squared. We're going to use 2 pi r. So it's really the exact same formula. One is the area of a circle, and one has the distance around a circle as your two things you're multiplying by. So I'll give you a couple more examples. Of course, if you ever played Pac-Man before, you'll know why Pac-Man's on here. Kind of the shape of Pac-Man might remind you of something. These first two on the bottom of your page, these next two on the bottom of the page, radius is 5 inches on the one on the left. Radius is 3 inches on the one on the right. Give you a second to maybe sketch them real quick. Draw a little piece of pie on there. Draw a piece of pie on there. Figure out the area of each sector. In other words, that beautifully shaded blue space. And figure out the length of the red arc that you see on there. And be careful, because maybe I'm trying to trick you on this one. I want you to find this red distance, not this distance over here. So I often do this on quizzes and tests. I'll often give you information that allows you to get to the answer, but not directly. This 300 is not related to this little red arc. This red arc is clearly less than 300 degrees. This is a good time to pause, kind of work on your own for a few minutes. Hopefully you get 4 answers here. You're going to see I leave my answers in terms of pi as well as decimals. So this first one would be the blue space here. So 5 squared times pi times 60 over 360. Of course, you might be looking and going, where did the 60 come from? Well, this entire thing's 360. If this is 300, that leaves 60 for the space we're concerned with, which is approximately 13.09 square inches. If you're trying to find the distance, it's the exact same thing, but you change this part to 2 pi r. So it's 60 over 360 times 2 times pi times 5. This is one where you multiply, you get 10 pi. If you simplify this fraction, it's what, 1/6. So I'm going to show this answer in two formats, which you should be comfortable doing it this way. As a decimal, it's approximately 5.25 inches approximately. As a fraction, it's 5 pi over 3. This is just comfort with fractions and multiplying fractions. So it's 1/6 times 10 pi, or 10 pi over 6 divided both by 2, and you get 5 pi over 3. You should be comfortable doing both of these. Most of these problems in the book ask you to give your answer in both formats. This is sort of like the SAT format. This is sort of like Hess format. I like decimals. A lot of math teachers, a lot of textbooks like to see it in exact form with pi still in your answer. The second one's a little easier, I think. So if you haven't already gone to that one, it's pretty simple. It's 20 over 360. That's the fraction of the circle we're looking at. Pi r squared is your area of the entire circle. Should end up being about half of pi square units. So, you know, whatever 3.14 divided by 2 is. And you could also write this pi over 2. You'll see it that way as well. Either one is fine. 1.57 maybe, something like that. That's the space on there. The second one is the distance, which is the exact same thing, but I got 2 pi r in there. 2 times pi times 3. So I think that also in terms of pi is like pi over 3, or 1/3 of pi. And if you were to do pi divided by 3, you get around 1.05, which I'm looking at. Didn't show up. Oh, it did show up on there. It's on the bottom of your screen. Sorry about that. I'll go back. There's my answer. 1/3 of pi, or pi divided by 3, which is approximately 1.05. And this, of course, is the fraction notation for it. If you were to do 6 times 20, you get 120. 120 divided by 360 is 1/3, or 1 over 3. Hopefully that makes sense. Pause here again for a minute, and I'll go on to the next one. When you're ready, flip the page over, get some drama on the next page.